Let's say we have a very simple example of compound interest where we have a starting principal amount of $1 and our bank compounds it at an interest rate of 100% yearly, but in this scenario, we'll compound it for every 6 months. So what would this look like mathematically? Well, we'll have our principal amount, which is just 1, multiplied by 1 plus 100% divided by 2, which is how many compounding periods we have in 1 year, raised to the power of 2, which is the number of compounding periods. So this will just equal 1 multiplied by 1 plus 0.5, which is just 1.5 squared. This will just equal 1.5 squared is 2.25. 2.25 multiplied by 1 is just the same thing. So we'll have $2.25 at the end of the year, since it was compounded every 6 months. So 2 times in that 1 year. Now, what would happen if we compounded more, right? What would happen if we just compounded, let's say, for every day in the year? At the end of each day, we compounded the interest yet again. So that'll be 365 separate pieces of compounding that's done. So what would this equal to? Now, just plugging this into a calculator, you would get 2.7145 ... It keeps going. So pretty much, if you compound it every 6 months, you get 2.25, and every day you get 2.7145. And if you just compounded it once in the whole year, it would obviously be 2, right? Because 100% after 1 year compounded with just $1 will just be $2 at the end of the 1 year, right? If it was just compounded once. Now we can generally see that this number is sort of like converging onto one singular number. Because if you just compounded it once, it would be $2. Then in this situation, we saw it was 2.25. And then for the 365, it became this. So what would happen if, let's say we had 1, which is our principal amount, and the number of compounding periods was simply just infinity, right? What would happen then? Would it just be a singular number that this converges to? Let's see. Let's try and make this numerically in Desmos. So let's say we have a principal amount 1, and that's multiplied by 1 plus 1 divided by, let's say, just a number a, raised to the power of a. And let's make a, let's say, I don't know, 100 million. What is this number? This number, as you can see, is very, very close to a constant. Or at least we can see that it's approaching some value that isn't growing towards infinity, right? And this value, for those familiar, is simply the value of e, right? This is the definition of e. It's when the limit as a approaches infinity of this sequence, right? This is basically the general format of sort of like compounded growth, compounded interest, right? Because this is sort of the most simple of a situation you could have, right? All other variations of interest are just differentiations of the value of 1, right? So we could say that E is like philosophically like the base or like the true value of compound interest, and all other like derivatives or like variations are simply modifications to this base amount.